All right, so today we're talking about the fundamental counting principle, which is this thing that we're going to use in order to count the number of ways that an event can happen. So if you've ever wondered, or you've ever been indecisive about like what kind of pizza to get, or what ice cream combination to get, or what donuts to get, the fundamental counting principle is the basis for how to figure out how many different possibilities there are, and it's really interesting, in my opinion, and really cool to see how many different ways some of these seemingly simple events can happen. So we're going to start off, and we're going to pretend that we own a small deli. And at our deli, we offer 4 types of meat and 3 types of bread. And we want to figure out how many choices do our customers have to make a sandwich. So one way we can do this, or one way we can use to figure this out, is a tree diagram, and that's this picture down here. It's called a tree diagram because it kind of looks like branches, right? It's branching off, and that's why they call it a tree diagram, because it's branching off into the different possibilities. So in order to figure out how many different possibilities there are, let's start with our 4 types of meat. We have ham, turkey, roast beef, and pastrami. Now for each of those 4 types of meat, we have 3 options because we have those 3 different types of bread. We have ham on white, ham on wheat, ham on rye, turkey on white, turkey on wheat, turkey on rye, etc. And so that leaves us with these possibilities over here on the right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibilities. Just by having 3 types of bread and 4 types of meat, there are 12 different sandwiches we can make. Imagine how many more options we'd have if we added in like 4 different types of cheese, right? Each of these would have to branch off 4 times. So the tree diagram is really cool because it shows you visually, and you can see all the different options for our deli. But if we added something in like 2 different types of lettuce, or 4 different types of cheese, or whatever it might be, the tree diagram is going to become pretty time consuming pretty quickly because of the number of options. So we want a shortcut. So another way to count the number of possible sandwiches is called the fundamental counting principle. And this is our shortcut. And the fundamental counting principle says that you don't need to use your tree diagram. We can actually just use multiplication to figure out all of these different possibilities. Now, it doesn't tell us the individual possibilities like a tree diagram does, but it does give us the number of possibilities. And that's what we're focusing on, just that number. So if we have 4 choices for meat and 3 choices for bread, we're going to take 4 times 3, and that gives us our 12 different sandwich options. And that's our fundamental counting principle. So let's put that into practice. At a restaurant, you have a choice of 8 different entrees, 2 salads, 12 different drinks, and 6 different desserts. And we want to figure out how many possible dinners are there, or how many different dinners consisting of 1 salad, 1 entree, 1 drink, and 1 dessert can we choose. Well, we have our entrees, we have our salads, we have our drinks, and we have our desserts. So we have 8 options for entrees, they said. We have 2 options for salads, 12 for drinks, and 6 for desserts. Now, if we wanted to make a tree diagram, again, this would be pretty time consuming, and we'd need a lot of paper to make it happen. Luckily, we can just use our fundamental counting principle, which says if we multiply these numbers together, it's going to tell us how many different options there are. So 8 times 2 times 12 times 6 tells us that there are 1,152 different ways that we can order our dinner. And that's what we're doing with the fundamental counting principle. It's just a way to figure out how many different possibilities there are. I don't know about you, but that's more possibilities than I would have guessed I would have for my dinner at a restaurant. Let's look at a couple more examples. Next example, how many different 7-digit phone numbers are possible if the first digit cannot be 0 or 1? So the different digits are the numbers from 0 to 9. So 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we said we can't use 0 or 1. That leaves us with 8 different digits that are possible. So we have 7 digits, 1, 2, 3, 4, 5, 6, 7. Okay? And we want how many different 7-digit phone numbers are. So we have 8 possibilities for the first number, and 8 digits we could use for the second number, and 8 for the third. Oh, hold on, apologies. So that's just the first 2, doesn't it? It says if the first digit cannot be 0 or 1. So we have 8 possibilities for that first number, but then for the rest of them, for the other 6 digits, they could be 0 or 1. So we have 10 possibilities for the rest of these. There we go. So we want to multiply these together then. And what this really boils down to is we're taking 8 times 10 to the 6th power. So 8 times 10 to the 6th power, you could do that in your head, or you could use your calculator if you want. Either way, you are going to end up with 8 million, right? 8 and then 6 zeros. That's what 10 to the 6th power means. There are 8 million different phone numbers using that combination. All right. Next question, we want to figure out how many ways can you arrange the letters in the word bad. So we have 3 different letters. 1, 2, 3. It's 1, 2, 3. But since we're just rearranging those letters, we can't repeat anything, right? Because we're just going from like B-A-D to D-B-A. We're just putting them in a different order. We're not able to repeat them at all. So that means we have 3 options for the first letter, because it could be B, A, or D. But then we use 1 up, so we only have 2 options left for the second letter. But then we use 1 up, so there's just 1 option left for the last letter. So that tells us that if we want to figure out the number of ways, we're going to take 3 times 2 times 1, which is 6. And this leads us into our next new piece, which is this new mathematical operation called a factorial, which is what we just did right here. So looking at a factorial, its definition is it's the product of all the integers from 1 to n. It's denoted by an exclamation point. This is a factorial symbol. And so n factorial is read as n factorial. Okay? So when we did rearrange the letters in the word bad, we ended up doing 3 factorial. So we wanted to, remember the product means to multiply. So we wanted to multiply the numbers from 1 to n. Well, in this case, 3 would be n, so we're multiplying the numbers from 1 to 3. And that's what a factorial is. So we're going to use Desmos to figure this out. You can do it by hand, just by multiplying, but just in case the numbers get kind of big, we want to know how to use Desmos. So go ahead and open that up very quickly. And then I'm going to go ahead and I'm going to, oops, maybe not. I'm going to try to split my screen. Oh boy. All right, here we go. So, to do the factorial, we type in our number. Looking at our directions, we open Desmos, and then we type in our number. So if we wanted to practice, we could type in 3. And then we go to ABC, and then we find the exclamation point or the factorial symbol. And look, our calculator tells us that our answer is 6, and that's what we want. So let's practice this a couple times. Let's see, we have 0 factorial, and this is just a definition. 0 factorial by definition is equal to 1. 1 factorial, oops, if I could type it in, 1 factorial is also equal to 1. So 4 factorial means we're taking 4 times 3 times 2 times 1, and if we type that into our calculator, it tells us that 4 factorial is 24. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1, and we find that 7 factorial is equal to 5,040. And if we wanted to, we could do this by hand. We could multiply it out, and we would get the same answer as our factorial. So the factorial, it's honestly just a little bit faster than doing it all by hand. So that's our new mathematical operation. We're going to use that, again, as a shortcut to answer some of these questions. So we want to know how many ways can we arrange the letters in the word math. Well, this is really similar to our example for bad. We start with 4 letters, M-A-T-H, and then we only have 3 for the next option, 2 for the option after that, and 1 for the option after that. So what's our factorial? So we're just going to take 4 factorial, and our calculator says that 4 factorial is equal to 24. So there are 24 different ways to arrange the letters NATH. How many ways can you arrange 5 photos on a shelf? Well, it's the same principle. We're just going to take 5 factorial. So 5 factorial would be, if I can get my calculator to work, 5 factorial is 120. There are 120 different ways to arrange the photographs on your shelf. That's a lot of different ways to arrange your photos, isn't it? Last but not least, we are studying a combination on a 4-digit lock, and we want to use the numbers 1, 2, 3, 4, but we don't care what order they're in, and we want to figure out how many passwords are possible. So again, this is really similar to our situation with BAD and with math, right? We're just slowly working through the possibilities. So since there are 4 numbers we're using, it would be 4 factorial, and 4 factorial, if you recall, tells us that there are 24 different ways to make a 4-digit password with the numbers 1, 2, 3, 4. So looking at our fundamental counting principle and our factorial, we just use them to figure out the number of possibilities. That's all that's happening here, figuring out the number of possibilities. So here's your assignment. Make sure you complete it and then submit it into Schoology.